All right, so from an intro to base systems, let's try some gigantic bases. Specifically, let's look at the lower base numbers. So if I'm in base 2 and I do a number 111,011,01, that looks like a monster. That's not 11 million. We would put a little TWO here to indicate that it's not base 10. We're not going to put our commas for our periods in there. There's no thousands or millions or billions, period. So here I have this number, and it's 1, 2, 3, 4, 5, 6, 7, 8 digits long. So I'm going to start by going 1, 3, 4, 5, 6, 7, 8 digits. And I could even put them in. Now, this is base 2, so I'm going to start with my 1's place value. 2 to the 0, 2 to the 1st, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, the 6th, and 2 to the 7th. 2 to the 0 is 1. 2 to the 1st is 2. 2 squared is 2 times 2, which is 4. 2 times 2 times 2, 8. 16, 32, 64, 128. These are the base 10 equivalents for the place values. So to figure out what this number is in base 10, I'm going to add up what I have with regards to the place value. I have 128, 164, 132, 0 16s, 18, 14, and 11. Now let's see here. That's 10, and that's 8, and that's 9, that's 17. So here I have 27. Regroup the 2. 4, 10, 13. That's the number 237 in our decimal system. So it took me 3 digits, 7 1s, 3 10s, and 2 100s to do what base 2 has to do with 8 different digits. And that's because my place values at this point are much higher than base 2's place values when it only has 3 digits. So that's what's going to be going on in the homework with regards to Dr. Kwark. So when I look at Dr. Kwark, first of all, we're not doing the bottom. We've been told not to do the challenge or the binary clock. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 sets of numbers. The directions say that we're going to figure out the base 10 equivalent for each of these 4 within them. Now you'll notice there's 1, 2, 3, 4, 5 different answers. So 4 of these will work with these 4. One of them will be left out. The one that's left out, we're going to take that letter. Let's pretend it's going to be the letter P. If the letter P is left out, that's going to go into the number 1 down here. That's why there's only 9 numbers down here, because there's only 9 sets of numbers. Some of them repeat. All right, so let's start with the first one. 101. I'm going to come over and I'm going to go with a beautiful blank piece of paper. If I have the number 101 in base 2, I want to think about my place values. 2 to the 0, 2 to the 1st, and 2 squared. 1, 2, 4. I have 1, 4, 0, 2s, 1, 1. 4 plus 1 is 5. This is the number 5. So I can come over here. I know that equals 5. Oops, my lights just went off. I wasn't moving around enough. So I can cross off J. So now I have 110. I might say this, 110. I have 1, 4, 1, 2, 0, 1s. Well, 4 plus 2 is just 6. This is going to be 6. I can cross that baby out. 1, 0. That's a good math joke. There's only 10 types of people in this world, those who know base 2 and those who don't, because the number 2 in base 2 looks like our number 10. 1, 2, 0, 1. So the number 1, 0, base 2 is equivalent to our number 2. That's a great math joke. So this is equal to 2. I can cross that one out. 1, 1, 1. 1, 1, 1. Oh, did I write 2 to the 4th there? That's totally wrong. That should be 2 squared equals 4. 1, 4, 1, 2, 1, 1. 4 plus 2 plus 1. So 6, 7. That equals 7. The letter E is going everywhere I see the number 1. E. All right. So I'm going to do 1 from set 8 because that one looks like a monster. Look at this bad boy over here. How many got here? 1, 2, 3, 4, 5, 6, 7, 8. Ooh, 8. We already did 1 with 8. So let me cover this up. Let's spin this baby around. I'm going to do one of these from set 8. I'm going to do B. So I need 8 digits. 1, 2, 3, 4, 5, 6, 7, 8. So 2 to the 0 always starts here. 1, 2, 4. 8, 16, you're always doubling. That's like the book, 1 grain of rice. 32, 64, and 128. So this number here, oh no, I said I'd do B. 101, 01, 011. Okay. Now I don't read this with thousands, I read it 101, 01, 011, base 2. Okay, so I've got a 128. I've got a 32, I've got an 8, I've got a 2, and I've got a 1. This is going to give me the base 10 equivalent. So I'm really looking at this. The nice part about base 2 is there's no multiplication to be done to figure out how much this place value is. It's just 1 of everything. That's going to be 10, and that's going to be 10. So I have 21, 5, 6, 7. This is the number 171 in base 10, and I can see that right here. So this is 171. I'm going to cross that one out. And then I'm going to continue on from there and do that. Remember, this is not tested. There's going to be bonus questions on this, on the quizzes and tests. So it certainly can help your grade, but it can't hurt it. And if it takes time to get better at this, that's totally cool. Take your time. Don't stress out. The reason I love bases is it helps us to learn exponents really quickly to understand what they mean. There's also a base calculator on my It's Learning pages where you can type in a number and then it actually figures out lots and lots of different equivalent values for different bases so you can check your work. You can check that out on It's Learning. Hope this helps.